Thank you all for joining, especially those of you that are quite a few time zones removed from Colorado. We're really excited today to have this webinar workshop for all of you so that we can share some of our latest progress in our Eagle behavioral and risk modeling project. And we'd like to share some of our latest results as well as solicit feedback. And at the end of this workshop, we'll have a session where some of you, if you're interested, can actually get your hands dirty and play with the code. This project is sponsored by DOE. So to kick things off, I'd like to invite Raphael Tisch from the Wind Energy Technology Office to make some comments. Raph, the floor is yours.
Hello, everybody, and thank you, Elliot, for that introduction. My name is Raphael Tisch. I am a senior project analyst with Allegheny Science and Technology. We're a contractor that supports the Department of Energy. I have worked in the wind program since 2009 and on wind wildlife and on our wind wildlife impact mitigation portfolio since 2011. I am standing in today for Joy Page, who is the technical federal lead for our land-based wind and environmental research portfolio, to provide you with this overview of our research program at a very high level and to sort of introduce this technology. So the primary objective of our environmental research portfolio is to develop informed technical solutions to wind wildlife impacts. We do that focusing in three strategic areas, the first of which is data collection and experimentation, which we find is important for understanding the risk factors that drive, or the factors that drive risk for our various species of concern to inform the siting and mitigation solutions. We primarily do this through research cooperatives. Next, we focus on development of monitoring and mitigation technologies informed by the data collection and experimentation work that we conduct. And we do this to advance technologies or measures to reduce fatalities at wind energy facilities in the most affordable manner possible. And we primarily conduct this through competitive solicitations known as funding opportunity announcements, or FOAs. Lastly, tying it all together, the third strategy leg of our program is information synthesis and sharing, to make sure that all the good research that we fund reaches all of our stakeholders and decision makers at various state, federal, and local levels to help them make informed decisions about wind wildlife impacts. And we primarily do this sharing through research cooperatives as well, and primarily through TETHIS at PNNL. So I highly recommend you check that out if you have some time. I go to the next slide. So our major focus areas from species perspectives are various bat species, primarily migratory tree bats, eagles, bald and golden eagles, and various grouse species. The near-term actions that we focus on, and we think about near-term as kind of being in like the 3 to 5 year range, as informing and catalyzing the development of technical solutions, sort of outlined in strategic areas 1 and 2 that I just mentioned, with our ultimate goals being to lower costs and improve environmental performance of wind energy, to preserve or expand the geographic areas available for wind development, and to reduce siting and regulatory uncertainty around wind energy development. Specific to eagles, the wind power program focuses on 3 specific research areas, which include reducing the uncertainty around the estimates of take at wind farms, developing and assessing the potential impact avoidance and minimization measures to eagles, which includes the research that we're going to be talking about largely today. And lastly, to develop and assess potential compensatory mitigation measures for bald and golden eagles. Back in 2019, we invited NREL to propose a research effort that would leverage the core capabilities of the National Renewable Energy Laboratory in atmospheric and wind farm computational modeling capabilities, and couple that with some unique eagle behavior and flight telemetry data to develop mesoscale and microscale models to predict how and under what conditions eagles utilize the landscape. As we'll hear about today, and as you may know, eagles are consummate soaring birds, and so they use landscape features and atmospheric conditions, thermal updrafts to navigate and to fly. So these models will help ultimately identify locations in and around wind farms with low likelihood of use by golden eagles, and so minimizing interactions. They can help siting wind turbines within wind farms to avoid those interactions. Wind turbines within wind farms. And it helps identify conditions associated with a high likelihood of golden eagle risk around wind farms. And then also we can use this information to potentially optimize our investments in wind impact minimization technologies, such as curtailment or deterrence at specific wind turbines by deploying them in the highest risk areas. So as Elliot mentioned, we welcome your feedback with respect to this research. Any areas you think we could improve on, anything, we're really truly looking for what you see as the high value research components of these efforts. So in addition to sharing them here, if you want to email us directly, my email address and Joy's email address are up on the screen, and we highly welcome any feedback you might have to help us improve and inform our research portfolios going forward. So thank you very much, and I hope everybody enjoys this webinar. I think it's going to be great.
Thanks, Raf, for all that background.
You're welcome.
So yeah, I forgot to introduce myself. My name is Elliot Kwan. I'm leading this project. So I will give a brief continuation of the background and introduction to kind of what we're doing here. So to summarize what Raf has already talked about, our problem statement is kind of the following. So risk is, I think a lot of us, as we understand it, is kind of difficult to characterize and very site specific, very project dependent, location dependent, species dependent. So in general, it's hard to generalize our analysis methods because a lot of them are either simplistic or just don't have enough data to support a lot of the conclusions we're trying to draw from our models. So this project aims to leverage a lot of modeling approaches, and that's why NREL is involved. So we're bringing in atmospheric modeling of the eagle flight environment. We're bringing in wind farm modeling to actually capture what happens in terms of aerodynamics around each individual wind turbine at the microscale. And we're also leveraging our expertise in machine learning. So we'd like to combine all of these approaches with our understanding of eagle behavior and the best telemetry data we have available. So given all of this, what we're trying to do is develop open source tools that can predict behavior and collision risk around wind plants so that we can inform both siting and operations of current and future wind plants. So we've assembled quite a team. This project was originally conceived by Mike Lawson, Charles Tripp, my co-PI, and as well as partners at the USGS, Todd Katzner, and Chris Farmer at Western Ecosystems Technology. And you'll be hearing from some of these folks later on today. I'd like to highlight two of our amazing postdocs, Rimple Sandhu and Regis Thaden, who have been doing a lot of the heavy lifting on this project. But you can see there have been a lot of people that have contributed to this project over the years. So the USGS is offering their expertise in eagle biology and behavior. West is offering their expertise in behavior and data analysis. And then Conservation Science is also offering similar expertise as well as a lot of unique insights into the data. And over the last year, we also brought on board David Brandeis from Lafayette College, who has done similar modeling work in the past. And so to really round out the team. And we've partnered with Duke Energy as well as Identiflight to kind of develop these technologies with them in mind, or sorry, rather these software and these analyses with them in mind. And over the course of the project, we've been trying to engage with industry as well as academia. So we have a steering committee and technical advisory committee that's all been aggregated into the advisory group you see listed there. So our approach is summarized in this somewhat busy slide. So in the left column, you can see all of the entities that we're taking into account. Within the scope of this current project, we're looking at the atmosphere and sort of what is the wind doing within this turbulent atmospheric boundary layer under different conditions, under different times of the day or different times of the year or different locations around the globe. We're looking at how the land surface varies. We're also looking at and considering how eagles differ in their characteristics and their behaviors. And we're thinking about the turbines as well. So our modeling framework includes essentially three components. There's the behavioral modeling that's based on updraft modeling that is then based on our atmospheric modeling across different scales. Our analyses, currently we have a way to predict relative presence. So this would give us an idea at the landscape or mesoscale, what the migratory pathways might look like and where we might expect conflict with wind plants. And we're currently in the process of converting this to a stochastic 3D movement model. And that's a big reason why we're meeting here today and to solicit input from you all, so the stakeholders and the end users of our code that we're developing. So these are the analyses that we expect to come out. So presence, predicting presence in the rotor swept zone, predicting avoidance behaviors, trying to characterize risky flights, and then if there was an incident, trying to understand the underlying conditions of what might have caused that, strike and how that might have been avoided.